In this session, we're going to introduce you to the concept of what we refer to as time value of money. Some of you have heard of these kind of expressions, what is the definition of time value of money, basically. And in the simplest terms, basically, is that a dollar today is worth more than a dollar tomorrow. So a dollar today is worth more than a dollar tomorrow. And the reason for that, of course, is inflation. We know that inflation erodes the purchasing power. Let me give you an example. Let's say you had $10. 10 years ago, $10 bought $10 worth of goods, let's say, all right? Fast forward now to today, so 10 years later, how much does that $10 actually buy in today's dollars? In other words, what is the purchasing power of that same $10? So 10 years ago, it bought $10 worth of goods. How much will that $10 buy today, let's say 10 years later? Given the fact that over the last 10 years, inflation has been relatively tame, 1.5%, 2%, that kind of stuff there. So even though it's been a very, very low inflationary period of time, you'd be surprised to know that that same $10 today will only buy $8 worth and 20 cents of goods. In other words, that $10 10 years ago bought $10 worth of goods today, it only buys $8.20 worth of goods. Another way of looking at it is that in order for you to have the same purchasing power, that $10, you would have had to have now $11 essentially and 80 cents. Okay, so in other words, to make up for that, that $10 good now costs you $11.80. So that's how inflation works. Essentially, is that inflation erodes the purchasing power. That's the real issue of the time value of money. That all said, there are two extremely, extremely important formulas that you must remember. Okay, these you have to maintain these in your head, so to speak. Okay, the two formulas are very, very important in our industry. The first one is what they call present value equals future value divided by 1 plus I being, of course, the interest rate, and N is the number of periods that it compounds. So N is compounding periods. So basically, what we're saying in the present value formula is, I would like to have a certain amount of money at the other end, a year from now, 10 years from now, whatever the case may be, okay? How much money do I have to give you now at a certain rate of interest? How much money do I have to give you now so that, let's say, 5 years from now, I will have X dollars, whatever. In other words, I'm looking way down the line. I'm saying I need this much money for whatever purpose it was, mortgage, this, that, whatever it was that you had in mind, okay? How much money do I have to pay now, deposit with you right now, at a certain rate of interest, so that at the end of that period of time, be it 5 years, 10 years, whatever, I will have whatever dollars that I had in mind. So, for example, in our industry, in life insurance industry, actuaries use a present value formula. So if you're ever asked what formulas to actually use, it's present value formula. You see, in the life insurance, we know the future value. The death benefit is the future value. Okay, so the death benefit, let's say, is $500,000. We also know N, because if you're 30 years old and it is, let's say your mortality is age 70, that means N number of periods is 40 years, basically. So we have that factor. And we also know what the interest rate is that we're going to be able to invest that money in over the next 40 years. And so therefore, from an actuarial perspective is, we know we have to pay $500,000 should this person die at age 70. It's 40 years from now. How much money does the client have to give us today, 40 years earlier, so today, at a certain rate of interest to make sure that we have that $500,000 when the client passes away, all right? And so the present value formula is used in the life insurance industry extensively. So let's go through a very simple example of what I'm referring to, okay? So let's say that 5 years from now, so N is 5, okay? 5 years from now, you're saying to me, I'd like to have $5,000 5 years from now. So the question now is, how much money do I have to give you right now at a certain rate of interest? What is that interest rate? 3%. Okay, so the interest rate is 3%. So we've got a period of 5 years. We know how much money we want at the end of that 5 years. And we also know the interest rate. Okay, so 1.03, so 3% is the investments. Now this is where the problem comes in when some of you may get confused. Be very, very careful with this money that's in the bracket. It's not 5 times 1.03. Okay, it's not 5 times 1.03. What it means is that this that's in the bracket gets multiplied by itself 5 times. So for simplicity's sake, what I've done for you is I've spelled this out. I said 1.03 times 1.03 times 1.03 times 1.03 times 1.03, okay, is 1.16. In other words, you need to multiply what's in the bracket by itself, in this case 5 times. So 103, 103, 103. So if you know 1, 2, 3, 4, 5, basically. So as you do this, to be on the safe side, you may want to cancel these because you can get confused basically as to. So you may want to cancel. Make sure you're not doubling up on any particular number. So basically, what's in this bracket really has to be spelled out. Has to be spelled out because, for exam purposes, you don't have a financial calculator. You have a very basic calculator. So you have to do this manually. So you have to know how to do this manually. So spell this out: 1.03 times 1.3, and so on and so forth, 5 times because the period is 5, and so that comes out to 1.16. So you take your 1.16 in this case. So the 5,000 divided by the 1.16 is $4,310.05. So if you say to me, okay, I need $5,000 in 5 years, and the interest rate will be 3%, I say to you, okay, based on what you just told me, you give me a check today for $4,310.05, okay, and 5 years from now, I'm going to give you back a check for $5,000. You see, it's a very useful formula because now you know how much money you have to deposit now at a certain rate of interest, so that at the other end you're going to get your $5,000. Okay, so the present value of that $5,000 is $4,310.05. Okay, so actuaries use the present value formula. In other words, they work their way backwards. Investment people tend to use a different formula. So in other words, if I give you this much money now, how much are you going to give me at the other end on maturity? And that's what we're going to consider is future value. Okay, so as an investment person, so if you're making deposits and everything else, it's the future value is what you're going to like. I'm going to give you money now. So you know what the present value is. I'm going to give you, in our example, $5,000. I'm going to give you $5,000 today. How much money are you going to give me 5 years from now? So once again, okay, so 5,000. 1.03, same situation, multiply it all out, okay, say, because it's 5 periods, so 1.16, 5,000 times 1.16 is $5,800. So if you gave me today, present value today, $5,000, and I invested that at 3%, and I invested that for over a period of 5 years, okay, at the end of 5 years, I'm going to give you a check for $5,800. So these are very important formulas. So present value, you're working your way backwards. You know where you want to be. How much do I have to give you now? With future value, say I know where I am, $5,000, that's where I am now. I want to know where I want to be. Okay, at 3% and so on. So these are two formulas that you will be tested on the exam, certification exam, as well as the provincial exam. So it is important that you memorize these particular formulas and how they work in terms of spelling out the money that's in the bracket. And of course, we'll see you next time.